All right, back to work. Any other question, homework problem, or we can start? Yes?
Something on homework
Number 3. Let me pick it up. Number 3. Which problem? All right. So, here we have a function, right? Let's write this function on a piece of paper. F, take what? Two natural numbers, and we'll give you a natural number. And when the first one is 0, we'll give you the second. And when the first one is greater than 0, we'll give you what? 1 plus f of xy. Oh, you are not seeing anything. I wrote it here, right? Should we play a little bit with this to get a sense? We could also put it in the spreadsheet, but probably plain is better. So, let's see how we compute f of 3, 3. Which of the two we apply? The second one. So when we apply the second one, what is x and what is y?
X is 2, y is 3.
X is 2 and y is 3. So here what do we have? 1 plus f of 2, 3. Are you with me?
Sorry, I was ready.
So I was talking to him, but I'm happy to talk to you too. He asked me this exercise, so I want to make sure that he's following. This is the first two equations are the definition of a function. Function takes two arguments. These arguments are natural numbers, 0, 1, 2, 3, 4, and so on. When the first one is 0, this function will give me the second. So if I have f of 0, 25, what is the result? Yeah? If the argument is not 0, what do we get? 1 plus that x, which is the argument minus 1, and y. Y we are not going to touch it. So if I call this one with f of 3, 3, what do I get? In this case, x is 2. So I get 1 plus f of 2, 3. Yeah? Yes. So now, let me compute of f of 2, 3. So this will be 1 plus f of 2, 3 fires the first or fires the second? The second. What is x and what is y? And so, this one here becomes 1 plus f of 1, 3. Yeah? Sam, are you following?
I think what you're doing right now is first the function, right?
Yes.
Okay. It's confusing to me why x plus 1 results in x equals 2. Like, without seeing the math. To me, it looks like you're assuming that because you're plugging in 3, so why would it not be 4 for x plus 1?
So, because the technical term is matching this one in red, matching this one to this one. Basically, what must be the value of x and y so that when I plug those values, I get f of 3, 3.
Oh, okay. So f of x plus 1, y is the representation for the value plugged in, so therefore f of x is 2.
Right.
Okay, all right, that's all. Okay.
And this is called matching. Pattern matching. All right, so if I continue now, how do I match this one or the one with 0 to f of 1, 3. Can I match the one with 0? No, because this one has 0 and this one has 1. There is no way. Can I match the second? Yes. What is x and what is y?
0.
X is 0 and y is still 3. So I get 1 plus f of 0, 3. Yeah? And so now I have to match one of those to f of 0, 3. Is the first or the second? The first. And so what is the value of f of 0, 3? 3. So what is the value of f3, 3? 6. Now, what did this one ask? What is the value of 4, 4? You see, the second argument doesn't play any role. Why doesn't play any role? Because we unfolded the recursion until we get a 0 and we just return. The first argument, which role plays the first argument? Yes? Say that again? Yes. So every time you come down a level, you add 1 to the function, right? So if I ask you, what is f of 2547? You should be able to say in the blink of an eye. Oh, you don't see. What is f of 2547? Yes, someone said it already. 72. Why? Because 25, every time we take 1 and we add it. So we do it 25 times. At that point we are down to 0. We just say the result is 47. And so it's 47 plus 1 at 25 times. You can code this easily in whatever language you want. You want to see a program that computes this one? It takes seconds to write the program. Oops, you are not seeing it. I'll write it in Ruby, and I have def f that takes x and y. And so I say if x is equal 0, what do I return? Then y. Else, what do I return? 1 plus f of x minus 1 y. Yes? This is my function. And this is the end of the function. And now I call f of 2547. Oops. Oh, I didn't say print, sorry. Print 72. Yes?
I think you said something a while back about the reason that you do the x plus 1y versus x minus 1y, so that
Yes.
your function is on like the natural numbers, you don't end up accidentally doing like a negative 1.
Right, or x plus 1 can never be 0. Right? So, but this language doesn't let me write it in this way, so I have to write it.
Oh, just because you said that the notation was confusing, and I agree.
Yes.
For when we do the problems of the thing.
That's the way it's written in many programming languages, including Haskell. Alright, so this was the recursion, right? You want to see some other recursion?
This one makes
I have time for everything. Which is problem number 4. All right. This one here. Problem number 4. So this is a function that says, look, if the argument is 0, I return a 0. If the argument is 1, I still return a 0. If the argument is some n plus 2, why do I write it in this way? Because if this plus 2 cannot be 0 and cannot be 1. At the very least, I start with 2. What do? 1 plus not the previous, but 2 previous. All right? So should we tabulate it? So we can write the program in Ruby. We can do it by hand, or we can put it in a spreadsheet. Still get the same thing. Should I start to tabulate it by hand? Like perhaps likely you are going to do in an exam. All right. So here I have n. Yes. And here I have f of n. And so here I want to know what is f of 7. So 0, 1, 2, 3, 4, 5, 6, and 7. All right? So when I have 0, what is the result? 0. 1, what is the result? 0. 2 says, go back and look at this one. 2, this n is 0, right? Yes? So, f of this one will be 1 plus f of 0. Right? So this one will be 1 plus f of 0, which is this one, which is 1. Yes? This one here will be 1 plus the 2 previous. Yeah? So 3 will be 1 plus the previous of the previous. So what do I have for 3? 1 again. 4 will be what? 1 and the previous of the previous, which is 2. And 5 will be 2. 6 will be 3. And 7 will be 3. Do we want to write the code to see how it looks like? Or do we want to put it in a spreadsheet? Why don't we put it in a spreadsheet that is simpler than writing the code? So let me take a new one here. Let me put 0, and here I put 1 plus the previous. Yes, thank you. And so here I have a 0 and here I have a 0, right? By definition. Everything else is 1 plus, sorry, this is a formula, so I need equal, is 1 plus 2 before. Oops. This one is 1 plus 2 before. And now I copy this one here. And I have it, and we were looking for these two. 7, the result is 3. You see how I did it? Here I have the argument, here I have the function. The first two I put the 0 because this is the definition. The next one is 1 plus 2 step above. And all these one are computed by doing 1 plus 2 step above. Good? Yeah. So what if we write the program like we did before? This is a function of only one argument, right? So let me call this G dot Ruby. It's still called F. The argument is n. So how do I do this one? If n is equal 0 or n is equal 1, then 0. Yeah? Else what? 1 plus f of n take away 2. Yeah? Oh, yes. Take away 2, I said. Yeah? And so let me close this one here. And first I do a P of f of 7. And I get the 3. But I can also do something like this. 1 10 dot do, this is my value n, and here I print what? N f of n. So let me do this 10 times. I don't know the syntax of this one because I always forget it. All right, and so here, this is exactly what we computed with the spreadsheet. All right, more questions on the recursion? Fantastic. Yes? Oh, so many hands. Yes? Bipartite graphs. So this is only a definition that we put there, and we didn't do almost anything, but let me get rid of the spreadsheets. So let's take the textbook and read what is there. So, what is a bipartite graph? Says that we can partition the vertices in 2 subsets. We saw a partition a second ago, right? What does it mean when we do the partition of the vertices? Some go on one side, some go on the other, none goes in both, and none is left out. So if we have 27 nodes are there, 10 will go on one side and 17 on the other, something like that. All right? Each edge of the graphs connect one vertex on one side and one vertex on the other. That's it. So, is that one a bipartite graph? No. Is this one? Of course, yes. So bipartite graphs you use in some situation where, for example, this is an action and this is a result. You have all the action and all the results, and you have different actions that will give you the same result. And you want to find, I don't know, which actions you need for that or something of this kind. I don't have a good example.
Is there a way to determine if the graph is bipartite?
Yes. I think you can write an algorithm. Now, you have a lot of partitions, so it may not be that efficient in the algorithm, but basically you have to see that you find let me write a graph here, but you said already that this one is not a bipartite, so you saw it immediately. Why this is not a bipartite graph? Tell me a reason why you cannot arrange the vertices in that way.
Well, and at least one vertex becomes very so you can't do that.
All right, so I say, look, there is an edge from A and B, right? So A has to be on one side of the partition, and D has to be on the other, right? Likewise, there is an edge from A to C. So D and C has to be on the same side of the partition, but there is an edge between them, so it's not a bipart. Yeah? Yes?
Could we make a decision tree or something?
A decision tree so I'm sorry?
I said, or you can just tell us if it's not on the test. That'd be helpful.
It's not on the test. So I think that you can do with a decision tree. If you make the right decision, it's very quick to say that it's not bipartite.
I'm not talking about in the context of being bipartite.
Oh.
Bipartite. I just meant like, can you just walk us through the process of just making a decision tree?
For the bipartite?
No,
Oh no, for
For any
anything.
arbitrary subject.
Yes, for an arbitrary subject. All right. So, suppose that you have to write a program where you pick the maximum of 3 numbers. You can try to write it in C or C++ or some other ugly language. But before writing it, one second, let me think a little bit what is the algorithm. Because the algorithm is less trivial than it looks. And so what is the algorithm to determine the maximum of 3 numbers? So we write the program and we know that the program is right at the first shot. We don't have to spend too much time fixing bugs. And so we have the 3 numbers. I write them here. A, B, and C. Right. And I want to find the max, largest. Say, well, let me compare A and B. So here I do a comparison between A and B. And the decision is true or false. If A is less than B, what do you know? What do you know? Toward, yes, Jimena, what do you know toward your goal?
Yeah, B is the maximum.
No.
You know that B is bigger than A.
Well, you know that A is not at the maximum. Right? Because B is bigger. So maybe C is bigger than B or maybe not. But certainly A is not the maximum. Right? And so now you toss it away and you do what?
Check
B less than C. And here you have the decision and you have a true and false. And if B less than C, what is the answer? C. Otherwise is B. Yeah? And so here, A less than B is false. So what do we know? right, B is not the maximum, so here we compare A and C, and again we get the true and the false. And if A is true that A is less than C, this is C. Otherwise is A. Yes? So now I think I got it right this one. I feel confident that this is correct. I can write my code, I know where things go. And if I look at the bottom, I observe that I have all the possible cases. If someone were missing, I would be very worried. So now, how do I write my program? I follow what I wrote here. I will say if A less than B, then
You switch to the
oh yeah, sorry, I already done the program. And so if A less than B, what do I do? If and I look here and I say, look, when it's true, I have to do B less than C, then C, else B, and in else I have sorry, I forgot an and here. In else I have if A less than C, then C, else A, and to test it I have P max of 7, 9, 5, and what do we expect? Max 3, I called it. Here I have it. And so with the decision tree helps me design this code. Before some people raise their hands and yes, Kim.
So I have a question about number 5.
Homework 7, number 5. Homework 7, number 5. Yes. You want to ask me the question, or you want me to do the problem?
I just don't get it.
All right. So if you have an expression, infix expression, the way we usually write, and we want the Polish notation, how do we do this one? What is the process that we do that? First, we compute the tree representation of the expression, and then we do a pre-order traversal. All right? So we start with that one. Let me write it here. This one is A plus B star. Yes, thank you. A plus B star C plus D. So how do we write the tree of this expression? First, we put all the parentheses there. Right? And so, where are the parentheses? This one, and this one. Yeah? Now we look at the operation that we do last. Which is the operation that we do last? Well, it's plus. That plus. So we start with this plus here. We put the plus. On one side we have what? D. On the other side we have the expression A plus. Yeah? So we do again. We do the operation that we do last. Which one we do last? The plus. On one side we have A, on the other side we have the expression B star C. What is the operation that we do last? Of course, it's the star because it's the only one. Alright? So this one here is the tree representation of that expression. For some things, the tree representation is much better. Why? Because there we have to figure out which operation we do first and last, and we know about precedence and associativity and all that stuff. Here, all this is not important. So now we do a pre-order traversal. You remember pre-order traversal? First you put the root. First you visit the root. Then you do a pre-order traversal of the left and the right. So now we have to do a pre-order traversal of this one and a pre-order traversal of this one. The D, of course, is D itself. What is the pre-order traversal of this one? Plus and a pre-order traversal of A and a pre-order traversal of star. So here I have A. Now I do a pre-order traversal of star, so I have a star, B, C, and finally I put the D. Yeah?
Could we do one more any problem at least?
Yes. Yes. So basically, to do this one, there are two steps. First, you write the tree. And then you do the pre-order traversal. How do you write the tree? You put all the parentheses, and then at the root you put the operation that you do last. And the two arguments, you do the tree of the two arguments. And you keep doing this. So let's do another one. Sam, you want to suggest the expression or I'll do it?
Just give us one.
You want to suggest an expression.
A to the n.
So let's do it with the numbers so we can compute it. So 2 to the third
2 to the third minus
minus
the expression 5.
5 minus 3.
Times.
5 times 3.
No, 2 to the third times 5 minus.
Oh, this is a. All right. All right. So here there is an operation that we don't see. So let me write it with the operation so we can write it on a piece of paper. So this one I use the caret like some languages do. All right. So this is the one that was given. So now I have to put the parentheses everywhere is important. So where I put the parentheses here? 2 to the 3, I put it between parentheses because this is the meaning, right? And then the entire thing. So now we build a tree. So at the root we put star because it's the last one we are going to do. And on the two sides we put the tree of the left argument and the tree of the right argument. So here I have caret 2, 3 minus 5, 3. So the first one is the one that was given. The second one is the one where every operator and every parenthesis is put there. And on the side we have the tree. So now we do the preorder traversal. The preorder traversal will be star, the preorder traversal of the left and the preorder traversal of the right. So the left will be caret 2, 3, the right will be minus 5, 3. Now, instead of pre-order, polish, we can do post-order, reverse polish, and then put the reverse polish calculator and compute and see whether we got it right. So, what if I do the post-order? Who want to help me do the post-order? The post-order, first you do traverse the left, then the right, and then you put the star. And when you do this one, you will have 2, 3, caret, 5, 3, minus, star. So this is polish, and this is reverse. So for the reverse polish, post-order traverse. Post-order. Post-order is first you traverse the left, then the right, and then you visit the roof. Yes?
Oh, sorry. I thought you were asking for the answer, but I see that you already wrote that. My bad.
So, should we now compute this with the calculator? First, what is the result of this one? The original. Now, what is the result of the original? 16. Very good. So now we compute this one, we should get a 16, right? So, DC is the name of my program, and we do what? 2, 3, caret, 5, 3, minus, oh, yeah, sorry. So I'm just writing here the reverse polish that I had on my paper, 2, 3, caret, 5, 3, minus, star, print the result. 16. What is the advantage of this? Go back to this one and try to do it with a non, this is was the original. And here actually I have a calculator that someone lost. I don't know. So this one doesn't even have the power. So here what do? I put the 3. Sorry, I put the 2. I put the power. I put the 3. I press equal. Now I have 6. And now what do I do with that 6? 8, thank you. What do I do with that 8? I have to put it in a register. I have to clear. I have to put the 5. I have to put the minus. I have to put the 3. I get the 2. Now I have to pull from the register and multiply. And multiplication is fine. If it was division, I couldn't pull it from the register. I have to put in the register the 2. Pull it from the register the 16 because the order matters. So in this way, I don't need any register. What is my register? The stack. The stack is the register, and it's making my life much easier.
I'm in CS250, so would it not even go to stack? We just maintain it the register? Because
So if you have a popular calculator like this one, which is a piece of junk, but this is what you have, this one has one register. So you cannot put 2 and 3 or 8 in a register.
sorry, I'm relating to like x86.
All right, yes, of course.
Okay.
But still, you have a fixed number of registers, right?
Yeah, six.
How many?
There's six. We put a off on this stack.
6. So if you need more than 6, you are lost. And the stack basically is unbounded because it's core memory, so you have gigabytes of things. You understand?
I was gonna ask you to go over 8.
8.
It looks like they're all right.
8 of this homework 7.
Homework
8,
8.
8. All right. Number 8. All right. So, what is the definition of subgraph? Oh, you don't see it. So, if you tell me why you ask the question, I can click on what is missing.
So like A is right all the time, but then D is also right all the time. And B and C are varying degrees of right sometimes. So would you rather D because it's always right, but then A is always right? Like
So let's make an example, all right? I write a graph here, a simple one. Sorry, you don't see it. This is a very simple graph, right? So, what is n here? This is my graph G, N, V. What is N? N is A, B, C, and D. What is V? Is the pair AB, BC. Let me write it quick. AB, BC, CD, DA. All right? The order doesn't matter. Yeah? So now let's pick a subgraph. Which subgraph would you like to pick? Are you okay if I pick this? Yeah? And so now we have, how do I call this one? G prime, N prime, V prime, right? Sorry, these are called E, I call it V. Forgive me. So what is N prime here? AB. And what is V prime? The edge AB, right? And so now let's go back to the question and look at this one. Is N prime contained in N? Yes?
I have a question about the wording of this, because the answer to all of these should technically be no, because they're both sets. So you're not going to have a set inside of, you're not going to have an n prime in n, because n prime is a set.
So, but here is contained.
Wouldn't that mean that the set was contained in n?
Yes, this is set contained.
Subset.
Subset, yes.
I guess I was just confused by the wording of like, because I mean, I said D, but I just thought that like, it would be like the elements of n prime are contained in n versus.
Well, the elements of, so we call it n prime. Now, you are right. One has to be a lawyer when does these things. So, I appreciate it, but we can see how the book defines a contain. So, if I look for contain,
So that basically when it says contain, it just means that you're looking at the elements, you're not looking at
No. Here you have an example where it says its edge set contains all the edges from G. So containment is a word for set. We can also look on Wikipedia.
Oh no, I got it, it's fine.
let me see. Here, I wanted just to find the page, but set contain. I am not on the network, sorry. All right, so I would claim that the wording is correct, but now I want to go back on Sam and answer this one. Is A true for this example that I'm making here? Is B true? No. Is C true? No. So the answer in this case, the only possible answer is A, in this case. Can you find a case where A is not true?
What about the case where A, B, B, and C are the subgraph, and then that makes
A is still true, is where I'm leading. A set contains, a set is contained in itself.
But the wording of B is any of the set above sets can be true.
Say that again.
So the wording of B is any of the above sets or the above can be true. Meaning A, B, and C can be true.
Yeah, you are right. You are right. This is poorly phrased. Yes, all right. You are right. I should change this one and make it better. I have to remember.
Well, like at the test, what are we supposed to do? Like, are we supposed to?
So we went through the drill. Is it possible? So in the test, I have someone reading the test and doing it before I give it to you. And so if this other person doesn't find any mistakes, means that they are not too poorly phrased. But you get 3 frees. So if one is bad, then you still get your A without any problem. No matter what you put the test.
You overestimate my abilities.
All right, so you get as bad an F as you would if...
Yeah.
I don't want to see you here the next time. So, this is a good opportunity. If you find something that you think makes no sense when you do the exam, don't worry, don't panic. Just put it aside and move on. You have 3 free. And it's possible that there is something like this one, which is not phrased very well. I agree with you. All right, I think we should close here because the time is over. Thank you for taking this class. I hope it wasn't too painful. Good luck with the exam. All right, so here there are many people that have questions. Let's see if I can. Is it long or short? Long. Then come to my office. Now, I mean, come around the 2.
Okay.
Come around 2.
Stuff we'll go over would be like homework 6, 7, and 8 for the final.
Say that again.
Which homework should I like go over and review for the final because I missed the Monday? So like 6, 7, and 8.
Yes. Yes.
Is homework 5 on it? Or
Everything is comprehensive. So you'll find the question on. This is why people ask me about the injective and subjective and stuff like that because they can be there. All right.
Hey, I totally forgot. I wanted to ask you. I know you talked about it in class already, but it was number 10 from the midterm when it was talking about the set of months.
Yes.
And we were just kind of wondering about that one because we were confused why it was like it was answer A, which was the set to 0. Yeah, to 0. Yeah.
So because one is a set of months, and one is a set of sets of months.
The power set. Yes.
Right. So it's like in a language like C, you ask whether an array of integers or an array of integers are the same. You already know that they are not the same because they can't be the same.
So when it's 0 represents there's nothing the same between them.
there is nothing right in
Shouldn't
both.
if y is the power set of x, shouldn't there be x contained in the power set? So
Yes,
shouldn't there be something
but x
about
is not contained in x. So really think.
Oh, I see.
Really think about a program where your set is an array. So one is an array of months. The other one is an array of months.
Okay,
So there is nothing in both.
I see what you're saying.
You cannot have that one element which is a month is equal to an array of months. There's no way.
I think I get what you're saying.
It's tricky.
Because then it would
Well,
be an individual bin that you're comparing.
You
to
see,
and a
this
power set of bins.
points on what
Yeah.
is the power set. The power set of a set of months is not a set of months. It's a set of something else.
Yeah.
So-
Yeah, because you'd have like A is like even if it was 1, 2, 3, and then B is the power set of it, but it's like it has 1, 2, 3 in it.
But those are.
But like if this also had one, like if this had that in it, then it would have a set of 1, 3 in the set.
Oh, but it doesn't. So this
But
is
it's not
just
inside of
a
it.
set of 1,
Right.
set of 2. Oops, sorry. That's a set of 3.
Yeah, like those are just the elements of the set rather than having a set of those elements.
Okay. So that's why I was saying like a set of January is not the same as January. Where the set January.